Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about onboard diagnostics or OBD. So let's dive deep into this puppy. Well, why do we need something so convoluted? Simply because our engines are idiotically complex. The modern engines are no longer drive by physical connections. They literally have zero physical connection. Brakes is only there because it has a manual override, but even that is not physically connected, meaning everything is drive by wire. Engine control unit does everything for you. So it is idiotically complex. It's so complex that there is a valve that dumps exhaust gas into your intake stream. We call it exhaust gas recirculation. So yeah, it is complex as hell is. And how the heck you figure out what the hell is going on? You need OBD. And another aspect is humanity early on, like in a late 70s when the car was going kaboom, people realized that it also has an emission problem, not CO2 problem at that point in time, emission problem, NOx emission, carbon monoxide emission, sulfur emissions, those things were really bad. So we needed a way to basically clean those. And again, cleaning those requires to add extra wiring, circuitry, sensors. Okay, cool, awesome. But here's the deal. You can't have these things as a critical layer, meaning if they fail, your car can still function. But here's the deal. How would the customer know that it requires some sort of repair? Or how would a government know that you have those systems or not have those systems? Or they are working within expected range? So they needed a way to validate. Basically, if the company said that this car has this sort of O2 emissions, this much oxidization during the catalytic converter is from this brand, they would need to verify it. OBD port gives you that data to verify that. So again, third party independent, so to say. And cars have way too many subsystems also, meaning from tire sensors to ABS. And all these systems are what we call mildly critical, meaning, yes, if your ABS system fails, your car will still stop. It will just be uncontrollable. So for that reason, you do need what we call a way to figure out what is wrong. And by law, there is a requirement that if you have any failure of engine part, generally back in the old days, like in 30s and 40s, if car is running, car is running. There was no scenario where it's like half crippled, but half crippled became a new thing in 70s with ECU units. So they're like, okay, we're gonna have by law a light, that light screams at you, which we call check engine light, and you're supposed to bring it to mechanic because it's like something bad has happened. So check engine light is just an alert system. It's like, take it to mechanic. But how would you do anything other than that? Well, for that you also need something, because again, alert. What the hell is the alert for? You don't know. So for that reason, we also need OBD. And standardization was kind of requirement because there were so many companies that if every company wanted to do their own thing, mechanics will literally go out of job instantaneously. And again, these things are so complex. Like right now, modern cars have horrifyingly large number of sensors and equipments. And if God help you, if you ever looked at tear down of a modern luxury car, luxury cars have like freaking motors for their seats and air conditioning for the seat. They have Peltier module at the seat, so it heats and cools. And I'm like, the wiring on them is like, holy damn. And God help you if it's an electrical system, it's like, damn. So fundamentally, we do need something that can tell what the hell is going on. And again, it has to be standard so every mechanic can work on it. So OBD was created. Now be mindful, the moment ECU came to reality and the sensor and this and all that became a thing, people needed a way to read those things. But those were what we call manufacturer specific, meaning General Electric, they had their own system on factory floor where they're like, plug it in, is it working or not, or something like that. And again, if you brought it to service center, they can plug it in and read it. But that was the early years. But 1988, Californians were like, yeah, this air pollution is getting out of hand. We have to fix it. And again, take the modern car, like let's say 2025 car, that is the worst polluting, right? Like let's say all the cars that clear the standard, pick up the worst one. If you traveled into 1988 in time machine, you would be shocked how clean that car will look. That will look like a magical machine. It's like, how this is so clean compared to what we had. So in 1988, California Air Resource Board, they create a mandatory law in that jurisdiction that OBD-I has to be mandatory, because again, that will allow people to understand whether the emission control system A is there, B working or not. So this was created, like a prongs like structure and all that. 1988. And things were good. People were like, you know what, this is cool stuff. So America is like, okay, cool stuff, cool guy. So let's look it up, copy paste it and improve it. So they made OBD-II, 1996. So onwards, a whole of USA started to get it. Again, country, like a large vehicle took some time, but like over time it was like, done, the end, go home. And by 2001, European Union is like, that's smart. Let's copy paste it. We call it European OBD. Again, they did not want to call it OBD-II because that would be too logical. So EOBD, that's the same thing. And by 2006, almost all countries have agreed to it, because again, there are only few countries who makes engine control units. So they're like, brah, you can make your own random BS, but it will charge you a few $1 billion. Good luck. So everybody over time, by like 2007 plus, almost all cars that are manufactured all have universal OBD-II protocol, so to say. So right now, meaning if you're buying any car anywhere, it will have OBD-II. And by 2010, India BS4 standard started basic OBD systems. Early stage implementation was like, things were there. Like again, if you imported a car from Ford or Toyota, those had those systems, but they're like India's law requirement was kind of lagging. And by 2023, OBD-II stage A was introduced, simply because India has a lot of two-wheelers, and two-wheelers, again, if you are not paying attention to it, two-wheelers have so much emission that we really had to apply some brakes on it. So 2023 OBD, a few years ago, only two, OBD-II was like, okay, let's make sure all the motorbikes have it. And 2025, few days ago, OBD-II stage B rollout was done, meaning every motorbike that is, let's just say optimistically, 2026 onwards will have OBD-II stage B rollout, meaning it will be complete OBD system, including continuous monitoring of emissions. That's the critical change. Back in those other systems, it's like you have a continuous readout and you have error code login, where it's like, okay, what else went wrong? But there is no logging of data. So in OBD-II stage B rollout, they made sure there is a memory in engine controller unit that will store all the data. So company can look into it. Basically, government regulation can look into it. What the hell is happening? Is if like company can say, oh, we made a very clean engine, but it only works for, let's say, 100 hours. So you clear 100 hours of engine testing and all that, like Volvo did that. And after that is like, bleh. So that should not happen. Again, that's why if there is any changes onto it, and they can double check it. That's why continuous data monitoring is important. You can't cheat if you have data logging. So 2025 OBD-II introduces system, because again, this also improves safety of the customer. Customer could not have done any tampering. It's like, we have the data. You're like, let's just say your oxygen sensor is, you was trying to make sure oxygen was like what 30% in the exhaust, so it oxidizes correctly, and then to improve mileage it reduces 10%, but it never does in day one. Like you start it never does that, because like, what if you are doing exhaust testing, but after like 15 minutes of driving, it's like, yeah, you are not doing exhaust testing, let's just switch it. It has a lot of clever mechanism to bypass these sort of issues. So OBD-II stage B rollout has compensation for that, and it also has tamper protection, meaning it will create a log if you do hululu to it. So this is OBD-II, this puppy. Almost everything right now, everywhere in this planet has it, including motorbikes. Motorbikes was the last thing, but trucks also got it. So what is the implementation of this? Implement as of 2025 OBD-II the end. If you understand OBD-II, you can understand almost everything. So that's there. So the physical port is known as 16-pin data link connector, this puppy. Now this generally has 3 blocks. Block A is basically the 4 pins you have, which is chassis ground. Basically, you must have seen there is a cable that is literally grounded to the chassis. So that is chassis ground. Then you have signal ground. Basically, circuit has an independent ground. So circuit ground is this that we call signal ground. And then you have battery power, which is directly connected to battery. If your battery voltage is 13 volt, it will give you 13 volt. There is no regulation on that. So many times, if you want to install what we call basically dash cams, and you want the dash cam with a sensory function, meaning if you turn off the key, it still records. But again, generally most dashboard camera will record like a time lapse, basically 10 frame per second, something like that, or 5 frame per second. You can still see something happening. So generally they will do that, but it consumes less for power. But where do you get the power? OBD port. Otherwise you can do wiring. So that can be done. And again, it also is the easiest way to measure what is the battery voltage without opening the hood. So these 3 wires are fixed in all OBD. And then you also have to understand there are certain pins in this puppy that government did not create rules for. Like why? Well, the idea was you only need 2 wires, which we call CAN low and CAN high, which is 6 number pin and 14 number pin. If you can read the data from that, that's the whole deal. The car runs on what we call CAN bus. So CAN is control area network, basically how you have LAN, something like that is CAN. Now CAN is 2 wire differential, so one goes positive, one goes negative. So it is very noise immune and it does transfer data. How much data? It can go upwards of 250 kilobits to some modern ones can go up to 500 kilobits. It's fast. It's more than fast enough. For telemetry data, it's like, bro, we good. We got this. That's why government did not authorized or like, lock down other pins. Other pins are free, meaning some companies have bit older systems which are like K-line systems that has a 7-number pin and 15-number pin. Some other has like, J1850 bus plus and bus minus. And again, luxury cars have a lot of use of those pins. So if you are like, okay, what if I plug the OBD scanner tool? Would it read? Most cars, yes, as long as it has CAN bus. But what if data is a bit too obscure? Let's say you are driving a Rolls-Royce. Rolls-Royce has a glass panel that like, goes opaque, and company can decide it's like some unused pin. They're like, okay, that pin is only dedicated to that. So that has been done. Again, it's up to the company. Some companies are like, nah, let's just put everything in OBD-II. If they have certain specific requirement, like some have PWM input and output. If they have specific requirement, they can put there, but generally they do not use to that. So let that be very clear. You can like, oh, I have OBD-II, I can plug it in, it reads, does not mean you can get the full picture. Especially if you look behind it and all pins are terminated, yeah, there are extra data that you're not getting. So, because again, we can't have true standardization, that will be too easy. So, two-wire differential system. And now we come into how the heck you actually read it. So OBD has modes. So mode 1 is live data readout, meaning I have a car that has speedometer. Okay, so it's a digital signal that just says the number. It does not show the engine RPM. I do not know why, like they were like, okay, let's save money by reducing RPM signal, but I can't read the RPM. I can buy something like, I had something like this. I did not like the design of it, that's why I don't use it. But you can have that. Like if your car does not have RPM output, you can put it. Many cars don't have that, especially cheap economy series. So you can plug it in and it will give you real-time readout from the engine RPM sensor. It will also log everything in real time, basically coolant temperatures, throttle position, lot of data is there. These are in mode 1, meaning the engine turns on, the key turns on, the mode 1 starts to dump data. So that's your readout. Then you have mode 3. Mode 3 is where it's like a logbook, where if engine sneezes, it's like kaput, backfire happens, this happened, that happened, sensor failure or all that data would be stored somewhere. That would be in mode 3. So mode 3 stores your diagnostic trouble codes, and check engine light would be triggered if there is anything stored in mode 3. Then you have mode 4. Now mode 4 is basically a poor man's engine fixing. You can just flush the DTCs. For example, sometimes again, it's a diagnostic tool. It can work because in modern engines are so complex. You could have a scenario where engine thinks a sensor sneezed and it created a check engine light, but sensor is fine. It happens continuously. So if you flush it and check engine light does not turn on again, that means it's actual fault rather than erroneous signal, false positive, so to say. So mode 4 just flushes everything. So many times mechanic will, that would be their first try. If some car brands are known for way too many false signal, they will like plug it in. They will not even open the hood. They're like, turn on the engine now. If it check engine light comes on, that means it's like, okay, something is serious going on. But again, this is pro level tool. You should know what you're doing with it, only then tamper with mode 4. And what we call DTC, aka diagnostic trouble codes, are common. Ideally, they should have been universal, but they are like half implemented, so to say. So you have trouble codes. So first letter would be B, C, P, U. So you have body, chassis, or powertrain, network. So that allows you to narrow it down. And then you have code 0 and 1. 0 is standardized code, as in like ISO, that will be universal everywhere. And then you have manufacturer specific. Everybody went cuckoo on that. And then you have affected systems, secondary air injection system, fuel systems, ignition systems, exhaust monitoring system, all that jazz. So, and then you have specific code itself, like number 12, number 35. So that will tell you. And I'm like, imagine a world which has improved past 1990 and we can actually have a dashboard in a car that has an LCD display or OLED and it shows what the hell is going on. But that would be too easy, life would be too easy. I have only seen one company that is trying to do that, that's Edison Motors. They are, because again, it's a very complex system, like, no, we have the technology. In 1970, we did not have megabytes of RAM. Now we have more than enough space in a micro SD card where it's like, hey, every error code, we can tell you what exactly is going wrong, rather than this code, figure out a giant manual, is like, what the hell is going on? Or have a specific toolkit that reads out that exact code. Because again, standard code, anybody can read. Manufacturer code, lol. Unless you have that manufacturer's lookup table. So that's the implementation. I really did not like this part, but such is life. Again, this really pisses me off. It's like, why do you have this code? I get it. In 1970, you did not have electronics. In 2010, we have electronics, man. We have megabytes of RAM. Lookup table is just a text. Say, like, air intake system failure. It's like, why? Like, why? Why do you hate the only planet you live on? So What about utilization? Now, utilization, it's basically, there are layers of it. First layer is very simple. The car mechanic check engine light is on. It's like, okay, what the hell is going to open up and study everything? That era is gone. So you open it up, start the running. If nothing is too obviously wrong, then you plug it in, plug this puppy in. So OBD at that point in time allows you to narrow down very quickly. Of course, it will not tell you. It might have that manufacturer specific thing where it's like, no, the oxygen sensor number 3 has failed. But in ISO code, it will be like oxygen sensor failure. It's like tear apart every oxygen sensor. So it allows mechanic to narrow down the search very quickly, very efficiently. And if they are dealing with certain models, they develop an intuition very quickly. It's like, oh, OBD, yeah, look into this manifold has broken. So that happens. That's the good part. Second, on large scale, now let the vehicle, math has this thing known as noise rejection, meaning if you have a lot of data points, meaning if you are dealing with OBD data of one car, like this, does not matter. But what if you have a fleet? Let's say you are a delivery company or a McDonald's or whatever have you, and you have a fleet of these cars. Collect data of all of them. You can easily figure out which car is going to break, simply because if you overlap all the data, like, month over month, one car that is about to break, it will have a weird readings. And it's like, tada, it does not work if you have one data point. It works very well if you have a lot of data point. So if you have 1,000 trucks, you'll be shocked how many data is like, whoa, what, this truck is about to die. You're like, okay, let's service it, let's fix it out. And another part is, it also creates a quick fix, meaning, oh, all the sensors are going wrong on this exact thing. You fix it, you create a spare part supply for it, and then you call up the manufacturer. Generally, big companies can do that. It's like, yo, my man, why the hell your oxygen sensors are always getting fried? So you can call them, and then they'll call up their supplier. It's like, whoa, what are you selling? Did you not do QC on it? So again, large fleet can really do good things with OBD. Again, they can reduce their cost because they will know which vehicle needs maintenance, what is going wrong, what exactly is happening with OBD-II. And then we have data logging. Now, data logging is basically upgrade of that. Is like, it can allow you to reduce insurance in certain countries, not everywhere, but certain countries. If you give company this data, first you are giving them a double-edged sword. First benefit, you get lower insurance premiums. Penalty, they can reject your claim. It's like your driver was driving wrong. It's like, how do you know? Well, OBD has speed and pedal position. So it's a dual-edged sword. But again, removing that from insurance part, it does allow preventative maintenance. That is really awesome. Like, that's like short uptake money. If you're like, hey, we are switching to 5th gear and it's always throwing this problem, that you can figure out what exactly is the cause. So if you are dealing with large fleet, all these data starts to make sense. And at that point in time, it's like, I got this. And emission regulation and lowering pollution, because again, you can figure out, like, is the catalytic converter working or not, because it does require certain level of behavior, certain characteristics of basically exhaust. Has that been met? Is it failing, or is they are pulling Volkswagen to it? So whatever have you. So these are the utilization. These things I have linked down below. They are not that expensive, but again, let that be very clear. The cheap readouts, super cheap. Then you have expensive one that is like, that can read far more companies, and then you have really pro ones that company actually verify that no, this BMW has this weird wiring, we read that. Yeah, those are ludicrously expensive. But again, for generic thing, even if you're not doing anything, this is like, buy the cheapest one, even Bluetooth login, it will work. Buy a data logging one, the problem solved. High end one is like very niche. Unless you are like you are managing 1,000 vehicles of one brand, I don't think it's worth investing that kind of money. So there are utilization. I've linked that down below, purchase links. So what can we expect in the future? Well, ideally, humanity should have created DTCs that are like, universal. Or we could have like, hey, what if we have a line like SMS, like, 100 letters, like, write what exactly is wrong. Instead of creating like this weird quotes, it's like, what if you write what is wrong? Can you imagine a universe where we are like, hey, our microcontroller has megabytes of RAM and gigabytes of storage? Like, even without gigabytes, like flash memories are also like multiple megabytes nowadays. You can easily store the whole lookup table there. So we should have gotten that, but like, you win some, you lose some. So different things, different brands. Some are like exhaust sensor failure, some are like air intake failure. It's like, what the hell? That does happen. That's why there are categories of OBD readers. And it does require manufacturer's lookup table. That will be clear. If you're like, hey, I'm going to buy this or buy this, I'm going to connect it and I'm going to be awesome. You're going to be better than most, but you're not going to be awesome. Unless the brand that you're buying from specifically specifies that we got this. Like, if they're like, no, if you're driving Honda, we got this. We reverse engineers Honda. We're like, nah, Honda is tricky. Honda is sneaky. We got this. Unless that, so that is there. So you do need manufacturer's lookup table. So that is there. And data logging is useful for people if people are wise about it. If they're like, hey, we gotta figure things out. And if you're noticing like your engine exhaust, if your coolant temperature is way too hot for ambient temperature, you're like, okay, the radiator might be dirty or the fan may not be spinning if it's an electrical one. So there are a lot of things that you can do. And here's the deal. Why do that? Well, the preventive maintenance is the cheapest option, like flat out. What is cheapest maintenance option? Preventative maintenance. Fix this before it goes kaput. So that's like short up, take money. And customers have to be wise enough to use it because these tools are not that expensive. So again, getting started, super cheap. Data logger, bit expensive. Again, data logger level, I say only do that if you are like, you're dealing with fleet. At that point in time, it makes sense. Some of them, advanced ones where they, because again, it's directly connected to the battery, they also have a GPS system and a SIM card system where they can dump data, like, creating a 24/7 tracker. Some of them can disable the vehicles indirectly because you do need some extra things. So there are a lot of things that can be done. Especially with fleet, it's like you should do this. If you have a fleet of vehicles and you have to maintain them, you should do this. And if like, hey, why this one car is braking itself so much, compare the basically throttle input of all other cars and this car. If you're like, hey, this throttle input is like, then you're like, hey, yo, my man, let your lead feet go, relax, feather it. And if they do not, fire them, because again, if your car gets kaput, you lose money. So there are a lot of options there. So this was a presentation on basically OBD system. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.